Good afternoon, everyone. My name is Ben Goldstein. I'm managing editor of Aviation Week's Advanced Air Mobility Report. I'll be your host for this upcoming session on battery technology, specifically as it relates to electric vertical takeoff and landing vehicles, or eVTOLs. As many of you may know, leading startups like Archer and Joby plan to launch services in the UAE as early as next year with eVTOL air taxis. In many ways, this will be a key milestone, not just for urban air mobility, but for battery electric aviation in general. But while electric aviation promises to decarbonize air travel and enable quieter and potentially lower cost flying, for some skeptics, the limits of batteries could inhibit the growth of this new industry in the coming years. So here to help me understand what is possible, we have an exciting panel of 4 experts from industry and academia. They were already introduced, so I will skip over those introductions. And we have about 30 minutes, so I'd love to dive right in. For my first question, and I'll pose it to all 4 of you, the industry has made big promises in the past about battery performance in aviation, which unfortunately has not always come to fruition. So is it your sense that this may be changing? Are the promises of electric batteries in aviation finally coming true? Or not? To those who think yes, what developments in specific are you most excited for? And for the naysayers, what are your reservations about battery electric aviation?
Okay. Hello, Ben. Good afternoon, everyone. I have worked in the eVTOL for about 15 years, and back in 2010, I designed the Project Zero. And that time, 2010, it only fly for 5 minutes. That time, we're using very good battery. Today, I believe we can fly at least for half an hour, 1 hour, if we don't have too much reserve. What's being overpromised, what's being underpromised? I think what's being overpromised is maybe how many times you can charge the battery. I hear some company even mention up to like 10,000 times. I think that's probably too much. I think maybe more realistically in the beginning, when we do implement this in a year or 2 years, I think we can probably expect 500 to 1,000 charges. The reason is typical cars, yes, you can do 3,000 charges, but they're using a very benign rate, right? You drive the car for 8 hours, 6 hours, 1 seat. But these eVTOL, we've pushed the battery pretty hard. So I think the biggest challenge is how can we design better battery to last longer charge and also drop the price of the battery. Because the battery price is the one that affects the direct operating cost the most in every eVTOL operation.
Look, Archer has made a number of promises, but battery technology is not one of them. The approach we took was actually based off of the Uber Elevate white paper that myself and a couple of other phenomenal folks at Uber wrote many years ago. And the approach has always been, we're not gonna go take any crazy leaps on battery technology. We're not gonna go rely on novel cell chemistries or batteries that don't exist today. So instead what we did was we took lithium-ion battery technology that exists today, very, very similar to what you'd find in a Tesla Model S. We actually hired a lot of the team from Tesla, from Apple, who are very detailed knowledge of what battery technology looks like today. And we built an airplane around that technology. So our battery pack uses almost 80% of the same technologies as a Tesla. And we're excited to use that battery to get to market as quickly as possible. Once we get to market, we will certainly look towards more novel battery chemistries, but not until we commercialize.
Well, I totally join you on this aspect. At CAPS, we had a similar approach, meaning not betting on a crazy improvement into battery possibilities. Even though we have to say within the last 10 years, the increase has been quite spectacular. We are sort of reaching sort of maximum right now. If we look at theoretical possibilities in terms of batteries, it's true that we are like maybe at 1/10 of what could battery do, but it's now a manufacturing problem right now. So looking at what batteries can do as of today and capitalize on that for good applications that you can address with those capabilities is a smart approach for today. But I still believe that in the coming years, there is many things that can be increased, and that's just a good perspective for market possibilities and range of actions for our aircrafts.
Yes, unfortunately, there will not be a super battery tomorrow. And for our air taxi, eCelos, we have a lot of clients. They like to have minimum 1.5 hour flight time. So we are an eVTOL, but we have twin hybrid on board. So we have a range up to 500 kilometers, and we have only 2 small battery packs until the battery have more density.
So I want to dig into what is the expected lifetime of an eVTOL battery. Particularly at launch with the first generation of battery technology. Hover and vertical flight modes in particular are very taxing on the battery. So what is the realistic expected lifetime of an eVTOL battery?
Okay, you're correct, Ben. When you're hovering, depending on configuration, a 7,000 pounds or 3,000 kilo eVTOL aircraft, you can pull anything from 1 megawatt power or down to 800 kilowatt. If you're lithium, you could put even up to 2-3 megawatt of power. And usually typical battery size about 200 kilowatt hours. So you can imagine you're pulling about 5 times the C rate, the capacity of the battery can handle. Typical car only draws about half a C to 1 C. So you're really working that lithium battery hard. Just like when you use your iPhone non-stop, what happened? It gets very hot in your hand. You can imagine these eVTOL batteries can get very hot, okay? So we don't want them to catch fire or anything. So in general, that's why you minimize the amount of hover time. Take off, hover, pull away. If you treat them nicely, I mean, you don't drain the battery all the way too low, and you don't quick charge them too fast, I believe the lifespan, it could be about at least 1,000 recharge full cycle using today's technology. But I do believe the battery will get better and better and better in this decade. By the end of this decade, I think we can probably double the capability and also the performance of today's battery. But it may not be the same chemistry.
Yeah, again, look, we took the approach of how do we get to market as quickly as possible using the batteries that exist today. So James is 100% right. Hover is not the best state to be in, but what we did was we said, okay, knowing that about our battery, how do we optimize every other part of our flight operations knowing that fact? So when we take off, we are in that hover state for less than 30 seconds the vast majority of the time. Then, okay, how do we think about the vertiports to enable that? How do we make sure as we design our vertiports, they're actually designed so the FADOs, the final approach and takeoff areas, are such that when you take off or land, you don't have to be in that hover state or that landing state for very long. So by our calculations, we expect you can do well over 10,000 flights. I think around 1,000 cycles is what we came out to as well. And the good news is those batteries are only going to get better and better and better every single year. So it's definitely a small concern, Ben. I don't think it's a big one.
Well, in my opinion, and the way we're designing the battery, we're very conservative, even though I think the question is what you do after the battery has been used for aviations. Like, once you cannot use it anymore, you still can use it for other applications like energy storage, ground-based vehicles, other things. But to us, to answer the question, with long time charging, slow usage, everything, like our business models account for 500 cycles maximum. 1,000 cycles is the optimistic approach to us, and we are hoping that to increase progressively within the next years. But yeah, as of today, batteries, like you cannot fully discharge your batteries. Like, you have to save up to 20% if you want to keep your battery's life cycle up. And knowing that even though after 500 cycles, 20% of your battery capability will be down, meaning that you will be running on a 60% batteries, 60% of your initial battery capability, well, to us, like 500 cycles is the maximum.
As we are a twin hybrid, we only need 2 small battery packages, and we take normal life batteries, LiPo batteries. So we think we will have a cyclus of around 2000. As we charge the battery during the flight on board, we don't need charging station, and with our suppliers, they say around 2000 cyclus.
Nikhil, maybe I'll direct this next question to you. Archer, of course, is planning to launch eVTOL service here in the United Arab Emirates. It's very hot here. How do you deal with those very high temperatures on your batteries?
Well, look, you have to separate two things. First is performance. Second is sort of life cycle of the battery. From a performance perspective, our batteries actually do better in high heat due to the lower resistance of the battery. And so from a performance standpoint, we're not worried at all about the heat. Now, separate though is the life cycle of the battery. So it's no secret that because of the temperature, because of the charging and cooling involved, that is going to take a higher toll on the battery. And so where that comes into play is the economics. Now you can look at that in one of two ways. One is, how do you optimize your operations around that so you don't hurt your economics too much? That really comes into when you charge, how quickly you charge, and the missions that you're running. That's number one. Then number two is obviously the pricing. So luckily here, we've seen, based on our analysis and our studies, a little bit more of a premium market because those batteries will probably experience fewer life cycles than they would in cooler climates. But it's not a negligible difference, but it's also not a huge difference. But the performance is actually better.
Hans, would you like to speak to why you're taking the approach of developing a hybrid architecture as opposed to going pure battery electric like some of our other panelists have done?
Yes, as I told you before, we have many potential customers, and they like also to fly from islands to islands, and there are sometimes no charging station. This is one reason. The second reason is the range they need. We offer 500 kilometers, flight time up to 3 hours, and at the moment we cannot do this with the battery. There is no chance. We work on a free linear piston generator with universities in Europe, and one alternative would be in about 10 years. You can see some pictures on our both. It will be a free piston linear generator, and we can use multi-fuel. We can also use hydrogen and all these other fuels.
Nikhil, if I may redirect it to you, obviously Archer is taking the opposite path with an all-electric aircraft. Clearly, you guys at some point you decided not to go hybrid. What's the reason?
Well, it all starts from the use case. Where's the business? So when I was at Uber, what we did is we took every Uber trip in the world, okay, and we said, what if that car trip was instead a trip by air? And we looked at literally every Uber trip that existed in the world, and what we found was that the most painful trips, the trips that consumers were taking every single day, causing them to be stuck in traffic, weren't actually long trips. They weren't these like 300-mile trips. They were between 30 to 50 miles. And so looking at that, we said, it's actually important to design a battery that fits that use case and an aircraft that fits that use case. So hybrid would give you 300 miles. It would give you more payload. It would give you more speed. We didn't want to build for that. We wanted to build for those urban commute trips that people are taking in mass quantities every single day. That's number one. Number two is we're not in this game to go build a small mode of transportation. We're in this game to build a large mode of transportation. We want to deploy thousands of vehicles all over the earth eventually. And we felt simply from a moral standpoint, from an ethical standpoint, if we're going to go build the next new wave of transportation, it was just critically important to us as people, as entrepreneurs, to make sure that that new mode of transportation was all electric from day one. Then number three is the batteries are getting better. They're getting 5 to 7% better every single year. That means your range gets almost 10% better every single year. So pretty soon, the range of these aircrafts, we're not even going to be talking about it because you're going to be flying plenty long enough to where, frankly, you're not going to want to go longer without a better plane and a bathroom and those sorts of things. So we feel really good about being all electric, and that's the path we're on.
And Paul, your company is developing a different kind of aircraft. It's a personal air mobility aircraft that someone would operate from their own house potentially. How does the all-electric powertrain enable this new application of aircraft?
Well, that's a good question. When we designed our aircraft, we decided to have it addressing the mass market, and the mass market is directly within the cities. This is where most, like the vast majority of daily travels are achieved. And as it's just been said, those little travel are not long enough. And if you want to go for full electric, especially when you don't have wings, you don't want to address long distances. Going for wings, going for hybrid, going for different technologies makes sense when you want to achieve longer distances, which is not our case. What we want for true is to evolve within the heart of our cities, but we want to do that silently, so having a very light aircraft. So our aircraft does not achieve long distances. We do a battery swapping at the end of each flight. So we have something small, compact, silent, that can evolve easily within the vicinity of your cities. That's how we made our choices. We don't want to achieve long distances, so we don't have complications like wings, hybrid. That's how we made our choice.
And for those of us who are developing electric aircraft, assuming that you're able to get these promised advances in battery technology in the coming years, what is the priority for the aircraft developer? Is it to increase the range or the payload? How do you think about that question?
Well, it's similar to what I said earlier. I think the vast majority of the trips are going to be, call it 30 to 50 miles max, and that we can handle with the batteries that exist today. I do think everybody in the field probably could use a little more payload. So today we're at about 1,000 pounds, which is a pilot, 4 passengers, and if you're lucky, a check on a hand luggage per person. But you're probably not quite there. And so I think the first use case is going to go directly towards payload. I think once everybody's closer to the 1,400, 1,500 pounds, everyone will be a little more comfortable. And then you'll start getting into range. But really, again, once you're at the 150 to 200 mile range, I don't think anybody wants to be in that tight of a space for that long. And then the rest will sort of go towards speed and maybe better interiors and those sorts of things.
I would go with something actually really different. If batteries energy density increase, what I would like is actually to reduce the payloads, meaning that, as we said, most of the travels, the distance won't change, like it's little distance. So actually having higher energy density batteries means that you can reduce the size of your battery pack inside of your aircraft, meaning you will consume less energy to move and you will be more silent. So what I would do is remaining on the same payload. I think everybody designing an aircraft is addressing a market for now with its targeted payload, number of passenger or cargo payloads. And we stick to our market, we reduce the size of our battery, so we reduce our energy consumption. We're also in a moment for environmental impact. Our energy consumption makes sense and we need to take care of it. So reducing the size of the battery will allow more efficient in terms of energy travels.
As we focus more on RAM, regional air mobility, and less on urban air mobility, so for us is the range very important, as our clients, they search also city to city, like from not Dubai, Abu Dhabi, but maybe from Ras Al Khaimah to Abu Dhabi. So we focus on the range.
I'd like to direct the next question to you, James, as a professor who studies battery technology. We see a lot of different battery chemistries and compositions that have been, floated in the industry. Silicon anode, lithium sulfur, lithium air. Is there any specific chemistry or composition in particular that you're excited about?
Okay. First, let me good point. You have silicon, anode, all the different types. Actually, let me just first explain a little bit about battery. Battery actually is quite simple. All it is have 2 nodes, anode and cathode, right? So basically imagine what you do when you charge a battery is that you're just like pushing imagine you're an electron, pushing you up the mountain. When you're using it, you're simply coming down the mountain using it, right? So now the different questions, which way we can quicker push you up, and when you can come down with more momentum, more energy, right? So the Different way to chemical, like you said, right now we use lithium. Lithium is very expensive, lithium ion. So you mentioned silicon. Silicon is very cheap, readily abundant on the earth. So we want to replace lithium by silicon as the anode. So when you push it up the mountain, the anode can release a bunch of energy quickly, and you want to do this as cheap as possible. So I think silicon has a good potential, and there are also lithium air and many others. Right now, I said, we really don't know. It's just like the stock market. We don't know which one's going to be the winner, which battery yet. Everybody is promising something. So the best way is, let's see, let them race. Let's see whoever is the one. One thing about battery is a commodity right now. A lot of company, even the car industry or cell phone, you don't actually really know what your battery in your phone come from. Whoever's the tomorrow, the best price, best support, best quality, company changes. It's like a commodity. Okay, so same thing for silicon, lithium ion, anything. Whoever produced the best quality, give Archer the best performance, the best price, the best safety, I'm sure you're just going to use the best one. That's it. You don't care what is the chemistry.
And if I can follow up with another question, the U.S. Department of Energy has a goal to produce a 1,000 watt-hour per kilogram energy density battery. Is this goal achievable, and what does it take to get there?
Yes, that's the United States ARPA-E, the Energy Commission. Their goal, of course, the holy grail is we want to go to 1,000 watt-hour per kilogram. Today is only about 250, 280. So imagine it's only almost one quadruple. How fast can we quadruple the battery? Imagine your iPhone will last 4 times longer. Fantastic. Probably, I don't think, unless somebody discovers something, won a Nobel Prize tomorrow, it probably won't happen this decade, by 2030. 1,000, that's quadruple. Maybe 2035, I hope. But even though you hear a lot of battery company, they promise, oh yeah, we have like 800 already, right? But that's in the laboratory. You're trying to buy one cell from them, like that size, they charge today $20,000 just to sell you the one cell only. You need about 10, 20,000 cells. So it only exists in laboratory, okay? So reality, I say 1 decade.
Nikhil, how do you design your aircraft with the view that battery technology is going to be improving in the coming years? How do you build that into your design now so that you don't have to redesign your aircraft at a later stage and go through, additional certification hurdles?
It's actually very intentionally designed to be able to upgrade the batteries on a continuous basis. So it's what we call line replaceable, which means that every year or so when we hit that 1,000 cycles, and we're able to reallocate or reuse those batteries in a different use case, we can easily replace. So we've got 6 batteries on our aircraft, 3 on each side, that each run diagonally opposed rotors. And what we'll do is roughly every year or so, we'll replace all 6 of them with new upgraded batteries. And the best way to think about these batteries are sort of like black boxes, meaning the connectors, the interfaces, the software, the way it interacts with the charging systems, that's always going to remain the same. But the innards, or sort of the structure inside of the battery, the cells, the chemistry, that can all change. So once we go to market with our current cells by one of our partners, Molicel, once we go to market with those, we can sort of use whatever we want, whether it's nickel or whatever it is, we can use any of those cells, substitute those into our pack, and then line upgrade those batteries. Of course, if it affects the performance of the vehicle, we would have to undergo some marginal amount of what's called an STS, so basically a slight amendment to our type certification, but that's pretty negligible as an effort, and that's something we would do in parallel while the aircraft's flying. So the end result of what you'll get is take a midnight aircraft. Every year we'll upgrade those batteries, and those will sort of magically become better without any changes to the rest of the aircraft. So it's a pretty cool sort of system.
I mean, this is especially true. Like, if you think about it, it's better to conceive an aircraft when the battery technology is improving than the reverse. Anytime it will just bring new possibilities, but the rest of the aircraft won't change that much. otherwise you could go further, you could have more payload, or just reduce your battery size, but all the rest remain the same. You have to think it upfront, but for electric propulsion, it's not that of a big deal.
For us, if there is better batteries in the future on the market, we can reduce the IC engines, can take smaller engines. Until today, we save 50% of CO2 in comparison with light turbine helicopters, and so we can reduce the hybrid, or we can take only one IC engine, and maybe when the super batteries on the market, we can take out the hybrid engines and fly only electrical like Archer.
Actually, I just want to add something. For me, the real improvement for batteries would not really be the energy density. As we said, we're addressing specific market, and actually what's already available is sort of sufficient for what we are doing. The real improvement for batteries is the life cycles. Coming from a battery is able to do 500, 1,000 life cycle to 10,000 life cycles would be a game changer in terms of business model, in terms of sustainability, and in terms of cost for the end users. That would be the real improvement.
So I want to return to a topic that was mentioned earlier in this discussion, which is how do we account for the second life of these batteries, and what happens to the batteries when they're no longer fit for use in aviation? How do we ensure that they're being used in a way that is sustainable and that will extend their useful life?
Okay, just quick, I agree. A lot of the chemicals right now currently we use inside the lithium cell, lithium included, phosphate, all the other, they're actually poisonous. So we do have to find a way to take care of the second life and how to recycle these poisonous rechargeable lithium battery. Okay, and for electric car, your iPhone, we can run them down 70, 80% healthy, still use it, right? With this aircraft, if anything go below 90% these life, we need to replace the eVTOL aircraft battery. So they have a much shorter life, okay, compared to other. In the future, yeah, it's going to be abundant lithium battery. That is going to be a problem for recycling.
So we will reallocate, reuse, and recycle in that order. What does that mean? It means let's say we were to start out operating between Dubai and Abu Dhabi, that's going to use the majority of the range in our battery. Over time, as that battery degrades, it's no longer going to be able to do a 60 to 70 mile mission. So what we would do is we would take those aircraft or take those batteries and allocate them perhaps to a shorter mission. Let's say we're doing 10-mile ferries back and forth a river, or a shorter mission like that where those batteries are actually still useful. That's number one, reallocate. Number two is reuse. There's a number of applications, whether it's energy storage systems at vertiports, or even Tesla's doing some experimentation with being able to reuse batteries at your own home for some home power powered by solar. So there's a myriad of use cases around reusing those batteries. And then third, when that battery truly has no more use left, we recycle it. So we're already working with a number of partners and providers to be able to recycle that battery, do it in a way that's safe, non-toxic, and sustainable for the environment.
Well, my colleague just said pretty much everything, but to sum up, you make money out of it. Batteries are a very valuable assets, and what we're using for eVTOLs are really top level batteries, and once they are not suitable anymore for our applications, they are way above the standards for many other applications. So using them in a slow manner, after having pushed them a bit hard during aviations, you use them slow so that you could push them for maybe 5,000, 10,000 cycles, and by the end of your usage, then you recycle them to the maximum you can.
As you use LiPo batteries, there is no toxin inside, and we take package from the suppliers. And once the cycle we arrive 2000, then we give it back to the suppliers. The only thing what we add is water cooling systems to not overheat the batteries.
Well, it looks like we are running out of time here, but I want to say thank you to our panelists for a really lively and engaging discussion. And to our audience, thank you as well. If you'd like to stick around, I'll be moderating another panel on drone integration in a few minutes. So thank you very much, everyone.
Thanks, Ben.
Thank you.